In this video, we're going to be comparing proportional parts of parallel lines. If you watched the last video about proportional parts of triangles, or if you already know about proportional parts of triangles, this video is very similar. The only difference being that we are cutting the tops off the triangle, and we no longer have those middle proportional parts. We're just going to have proportional parts dealing with the outer lengths or outer values here. We could have 3 parallel lines or more. So in this video, I'm just going to focus on examples that include only 3 parallel lines. So for instance, let's just make sure we can compare corresponding parts. If I talk about a comparison of the left side, AN to NH, so comparing the top left side to the bottom left side, I know that that corresponds to the top right side compared to the bottom right side, so VI to IS. Another comparison we can do, comparing a piece to a total. So I could have HN compared to HA, so the bottom left piece compared to the entire left side. Well, that would correspond with the bottom right side compared to the entire right side. So IS to SV, or SI to VS. Another comparison we can do, similar to that last one, VI to VS. So if I compare the top right side to the entire right side, that would correspond with the top left side compared to the entire left side. So AN to AH. And then one more proportional part that's true here. If I'm trying to compare HN to SI, and I'm comparing the left side to the right side on the bottoms, well, that would correspond proportionally to comparing the top left side to the top right side. So AN to VI. So there are the proportional parts given 3 parallel lines. Let's practice some actual examples with some values in there. So lots of different ways that we can set up our proportion to solve for a missing piece. One way that we can solve for x here is by comparing the left side, the left pieces. So the top left side compared to the bottom left side would correspond to and be proportional to the top right side compared to the bottom right side. So 15 to x is equal to 12 to 8. We can cross multiply and solve that proportion. Another way that we can do it is compare the top pieces to the bottom pieces. So I could say the left top compared to the right top should be proportional to comparing the left bottom to the right bottom. So 15 over 12 should be equal to x over 8. And again, we can cross multiply and solve, and we get the exact same product and the exact same solution. One more way we could do it, slightly trickier way, is to compare a piece to its total piece. So for instance, if I compare the top left to the total left side, well, the total left side is 15 plus x, so my ratio would be 15 to x plus 15. And then the right side, I would need corresponding parts. So since I use the top compared to the total, I'm going to say 12 compared to the total right side, which is 20. And if we solve that, we actually get the exact same answer. So lots of different corresponding proportions that we can use to solve for an unknown length or value. Here's another example. So one way we could do it is to compare the top pieces to the bottom pieces. So x plus 1 to 6 would be proportional to 2 to 4. So we could cross multiply that proportion and solve. We could also set it up to compare left pieces to right pieces. So I could say x plus 1 to 2 should be proportional to 6 to 4. And again, cross multiplying and solving either of those gives us the same product. Just be careful when you cross multiply what's called a binomial, more than one term here. We got to make sure and distribute, so 4 times x and 4 times positive 1. And when we get our solution, we should get the same solution regardless of how we set it up. X is 2. And one more example here. Sometimes comparing the parts is not enough. Sometimes we don't have enough information. We got to include the total length on the right or the left side. So in this example, we're given 10 and 5 on the left side, but we're only given 3x on the bottom of the right side and told the total of the right side is 18. Now we could solve for that missing piece up on the top right there. That would be 18 minus 3x, but that expression is not going to necessarily be any easier. So what we can do is compare a piece to a total. So if I know I'm going to use a ratio involving the bottom right side to the total right side, 3x to 18, well, then I need my total on the left side. So I'm going to add up my left side and get 15, and then I can compare the bottom left side to the total left side, so 5 to 15. So we could cross multiply that and solve and get x equals 2. We could use that value 18 minus 3x there and then compare the pieces, compare the tops to the bottoms, set up a ratio saying 10 to 5 is equal to 18 minus 3x to 18. Or we can do 5 to 3x is equal to 10 over 18 minus 3x. All of those are involving corresponding parts, and so they all should get us to the same exact solution, x is 2. So there's proportional parts of parallel lines.